Hello everyone. We are presenting the final project presentation here, which is the modified Mitnick Attack with CAM Overflow. I'm Rahul Banerjee and my teammates Tanya Agarwal and Avinash Gupta will take over once we receive their slides. So we are performing the Mitnick Attack, which is a type of a man-in-the-middle attack. A man-in-the-middle attack is a type of cyber attack which communicates between two parties which are intercepted, often to steal login credentials or personal informations, and usually they are spies who are spying on victims and they sabotage communications or corrupt data as well. At the Mitnick attack is something which is a special case of a TCP hijacking, and these hijackings take place in such a way that a connection is established between the victims A and B, where victim is the X terminal here and the B could be a trusted server. So Mitnick attack is where the trusted server doesn't even get to know that the attack is happening, and the X terminal, which is the target or the victim, often communicates with the attacker thinking that it is communicating with the trusted server. Now Tanya will explain the features we have implemented and Tanya will take over.
Hi everyone, so I'm going to explain what features we have implemented individually. So starting with the CAM Overflow Attack that has been implemented by Rahul Banerjee. Then Syn Flooding has been explained by me and implemented by me as well. And the last feature that we have implemented is three-way handshake that has been implemented by Avinash Gupta. And now we have how we have set up our network that will be explained by Avinash.
Okay, so hi everyone. For the network setup, we have created three virtual machines. So first one is the attacker, the second one is the victim, and the third one is the trusted server. For the attacker, we have assigned the IP as 10.9.0.5. For victim, it's 10.9.0.6, and for the trusted server, we have assigned as 10.9.0.105. We would be performing all the attacks and three-way handshake using these three virtual machines. Okay, so now I'll be showing you the Docker Compose file where I have assigned all these three IPs. So this is my Docker Compose file. As you can see, I have created four services, four servers, different servers, and the first one is the attacker, where I have given the image of Ubuntu 21 and then the name of the server with the IP address of 10.9.0.5. After that, we have created another virtual machine for the victim, which has the IP address of 10.9.0.6 as I explained before, and the third one is the server with the IP address of 10.9.0.105. We have also created the fourth machine, but we have not used it in our project as of now. So for the next slide, we would be continuing with the CAM attack, which would be performed by Rahul.
So before we move on to CAM attack, I would want to explain what our proposed project is. So the proposed project deals with the famous Mitnick attack, which is based on the man-in-the-middle concept, and we have added the concept of CAM Overflow Attack, which makes this entire attack an effective one. The backdoor file planting on the Mitnick attack is something we couldn't establish on our Mac systems, and therefore we have supplemented the same with the CAM Overflow Attack, which I will explain here. So here I will be explaining what CAM attack is. Switches operate by building a reference table of the MAC addresses and corresponding switch ports. Based on the destination MAC address, the switch knows which port to forward the frames to. This table is called the context address memory, which is also known as the CAM table. The switch can hold only a specific number of MAC addresses in this table, depending on the resources available to the switch. A CAM overflow attack occurs when an attacker connects to a single or multiple switch ports and then runs a tool that mimics the existence of thousands of random MAC addresses on those switch ports. The switch enters these into the CAM table and eventually the CAM table fills to capacity. When a switch is in this state, no more new MAC addresses can be learned. Therefore, the switch starts to flood any traffic from the new hosts out of all the ports on the switch. A CAM overflow attack turns a switch into a hub, which enables the attacker to eavesdrop on a conversation and perform man-in-the-middle attack. Now I will explain how exactly CAM attack works. As you can see in this code, we are setting a variable I which goes on till the range of 9000. This particular variable trim is calling the scapy.all.ether function, which captures the Ethernet packets using that function. We are also declaring the MAC address of the victim machine, and at the same time we are also declaring the MAC address to broadcast across the network. So we will be showing both the use cases where we are transmitting the random MAC addresses first to the entire network and then to the victim machine. And then we are creating the list of fake MAC addresses which will be used to populate the CAM table at either the victim or the broadcast. And then these fake MAC addresses are being sent to the target machine. So now you can see the three virtual machines which we have created. I will type ifconfig to confirm which machine is assigned to which unit. So as you can see, the first machine, where the mouse is being pointed, is actually the attacker. The second machine, which has the IP address of 10.9.0.6, is actually the victim. And the last machine is actually the trusted server. So now, since the code is set up in such a way that there will be a broadcast to the entire network, we'll be running the TCP dump on both the server as well as the victim. And this will be capturing all the packets which will be sent from the attacker's side. Our scripts are written in such a way that we'll be running all our scripts on the attacker's end. Now I will execute the code and you will see how the entire network is flooded with the random MAC addresses. You can see multiple of addresses being flooded, and these are all MAC addresses which go on to both the server as well as the victim. I will stop the attack and then I will change it to just the victim. As you can see, I am now changing the attack destination to just the victim, and the MAC address of the victim is actually being entered. The code is designed in such a way that we have already fed the MAC address of the victim here. Now I will run the script, and this will only affect the victim machine and not the trusted server. As you can see, the victim machine, where I'm pointing the mouse pointer right now, is being flooded with random MAC addresses, whereas the trusted server is no longer flooded with random MAC addresses. So this is how we are doing the CAM attack. It can either affect a victim machine or the entire network. And now I'll let my further teammate to carry on.
Hi everyone, I am going to explain what is Syn Flooding and how I implemented the same. So the TCP Syn Flood is a type of distributed denial of service attack that exploits part of the normal TCP three-way handshake to consume resources on the target server and render it unresponsive. So basically the receiver reserves a slot for the new connection and sends back a SYN or a acknowledgement packet. Then the attacker never completes the connection. The attacker sends lots of SYN packets, thereby consuming a lot of connection slots at the receiver. And I'll be showing this the same with the demo. First, I'll be showing you the Python file. So in this we are taking the source and destination as argument, and then we are defining the source IP address and the port IP address along with the destination port and IP address of the same, and then we send them as a packet using like send packet. And we have defined what our source IP addresses and what our target IP addresses. Then moving on the terminal, so the first machine is of our attacker, then the second machine is of our server, and the below machine that you can see is of our victim. So now on the terminal, the victim server is on listening mode because of the tcp-mp dump command. So now I'll be selecting the flooding.py file using the command python3 flooding1, that's the name of our file. And now you can see that the Syn flooding is in process, and the attacker is flooding the victim machine, and the victim machine believes that the server is sending the acknowledgement, but server has no clue about it. So hence it is a sequential pattern. For every Syn packet there is a reset packet that is coming, and that's how we have implemented Syn Flooding. Now further connecting with the same, we have three-way handshake that will be explained by my fellow team member Avinash.
Okay, so now I would be explaining the three-way handshake. So the TCP uses a three-way handshake to establish a reliable connection. The connection is like full duplex and both sides synchronized and acknowledged to each other. And then the exchange of these four flags is performed in three steps: synac, and then the acknowledgement. For the first step, the client sends the synchronous message to the server, and then in the second step, the server sends the synchronized packet as well as the acknowledgement package to the host A, which is the client in our case. And then the third step would be the client acknowledges the response of the server, and then they both create a stable connection will begin after this three steps, and then the actual data transfer process can begin. So I'll just give you a quick demo about it. For this we have three different Python files. For the first step we would be doing the Mitnick spoofing attack, and this is the code for the spoofing attack. In this we are taking the source IP address and the destination IP address. The source is the server and the destination is the victim in our case, and we have defined the port number. The source port number is 1023 and the destination port is 514. The flag is S means the sequence synchronous messages. For that the flag S has been defined here, and we are sending this packet over here. So now let's start with the demo. Let me just clear all the machines first. Okay, so in our client and the server we would be running a TCP dump with the filter named TCP flags, and it would just show the it will just cast the network files which has synchronous and acknowledgement inside the network packet. I would be running this on the both end, the victim and as well as the server. After this we would be running the first Python file, which is the spoofing one. As I run the spoofing one, you can see here, so as I hit the Python script, as you can see on the victim machine, it has sent the file to server with the sequence number of 77, this number which we have mentioned in our file. And over here you can see that the file has been received from victim to the shell, which is the server, and the acknowledgement number is 77835537, which is the synchronous number from the victim machine. So this was the first step. After that we would be running the next step. So this was the first step, then I would be running the second step, which is the synac file. When I run the synac file, you can see on the victim machine the server has sent a message over here with the sequence number of this file. I'll just show you the code for the synac one. In the synac you can see the sequence number has been changed to 239, which ends with 446, and this is the same number which is being shown over here. The victim has received the sequence file from the server, although the file has been sent by the attacker. So the victim believes that the file is being sent from the server, but it instead sent by the attacker. And after that we would be running the third step, which is the acknowledgement file. I'll just open it up. In this you can see again the source and the destination has been defined, and the flag is set to be A, which is for the acknowledgement, and the sequence number and the acknowledgement number has been changed for this file again. So I'll be again running the code. So as I run the code, you can see over here on the victim machine it shows that the server has sent the file to the shell, which is the victim machine, and the acknowledgement number has been and the acknowledgement number can be seen here, which is 36808962251, which was present on the file which I showed you. So this is a three-way handshake. So now the attacker has done the three-way handshake with our client, and now the attacker has all the access to the victim machine. He can now send any data, or he can create any files which he wants to create, or he can even hack the data present on the victim machine. So this is the three-way handshake which I just performed. Okay, so to sum up, we have enhanced the performance of the Mitnick attack by the usage of CAM Overflow, and this is how we have to summarize the entire project. Thank you so much for watching.